So what is data? What you see on the right hand is the ideal data. You're going to do the data mining. This is just a little section of the data mining project, try to find what kind of mortgager is a tax return is cheating. Try to find those weird number combination, and then you have a likeness to be cheating. You know, NSF only poll like 2 to 3% each year to see who is cheating and the tax return. But of course, that's not enough to cover the crime. But what they do behind the scene, there's a huge data mining project going on to look at the anomaly. That's one of those. So in the ideal case, you can see it's just a table, or you can call it matrix, and you can call Excel. You can say any name, depends on the tool. But one thing in common, you have rows and the columns. So we have a terminology. In each of the row, either you call it one object, one record, one instance, or one data interest. Doesn't matter. This is just one case. What's important for your model is the columns. That's we call it the attributes, or sometimes we use the feature in these two words to talk about the columns. So-called the data mining model is nothing more than I want to build the relationship. Look at the last column. It's called the cheat. That's what I consider. That's the dependent variable on the other three attributes: the refunding, merit status, taxable income, and those things. So a classification model is nothing more than a dependent relationship between the last attribute. We have a name for that, called a class. That's a class. What you classification? You define a decision as a function of the other three attributes, or could be other 300 attributes, depends on your project. So those are the terminology. But there's a long way to get to there. So we get the so-called the data set. The data set is the whole data you are working on. It could goes from 30 data objects to 3 millions or to 32 terabytes. It depends on your project again. We know what it means a data object. That's the row you're talking about. And then the attributes are the columns. And the other one we call the model. It really depends on what algorithm you're going to use. That's what we are doing. It's a particular mathematics model. So now let's look and understand the different types of attributes. That's all really matters, because when we say data mining, it's not like statistics. In statistics, when you design your experiment, you already know exactly how you're going to use each of those data attributes. That's how you design it. And they all come to the way you want. But the data mining, we are doing the recycling, the second use of the data. The technical mass was produced, not produced for your purpose. You just try to get it from the like a landfill for something very precious. Maybe somebody lost a diamond ring or something. So remember, you're going to deal with very filthy, massive, chaotic data. So understand the attributes and understand what you choose, what you filter out, what you can do a little change, what you should not change, and how do you sampling that make the whole deal of success or failure. Okay, first understand what type of attributes you deal with. You have so-called qualitative and quantitative. That's just like our math. If you think about what kind of math you do, I will tell you I'm working on continuous math. Continuous means my domain is always a real number. Like I teach calculus, differential equation, partial differential equation, the whole sequence, we deal with the continuous function, right? But there's another type they call graphic theory, discrete math, logic. They deal with discrete math. Then you get those qualitative data, like male, female, married, non-married, like those. And that's the first way to quantify it. So you have a qualitative attributes and the quantitative attributes numerically. So sometimes we need to change from numerical to discrete to quantitative. So now, let me repeat this again. You need to understand, you need to do some change. But what type of change is good, what's bad, is very important. I'm going to ask you those questions again. Let's just look about how do we rate the bonds or mutual fund. Well, you're going to deal with data that are very diversified. From the capital, you're talking about multi-millions, billions dollars, to the tenure of the boss, the CEO, 2, 3, 4 years, and for the how many member in the board of trustee changed those numbers. So how do you compare all of those different things together? And you need some change. But what you can, what you should not, it's really beyond the math. It's your domain expertise, and it means you know what you're doing. Okay? So if you do not know your data, you can get a PhD in data mining. Will not help you much. So first I talked about discontinuous and the continuous. Basically, this is the two big category. We're going to talk about this later. Example, you get plenty of. Anything come from the natural, pretty much is continuous, like temperature, heater, velocity. Anything come with a human being made, it's discrete. Okay, like male, female, age, ID, and all those things. That's easy to distinguish. Time. So the first thing is the categorical and the numerical. You can call it discrete or continuous. But even under the categorical type data, discrete type, you still have two different types. One is called the nominal attributes. Nominal, that means it's just the name. The only purpose you get this is distinguish from other. For example, male distinguish from female. And the section of industry, government, academic, business distinguish each other. But in here, there's no order. And the student ID, if I swap the two student ID, it will not affect the result, should be. The only thing is they're the same or not the same. Are you with me? What is categorical? The only one is nominal. The only thing you care is are they the same? If there's not the same, there's no other meaning. So as information science, when you get the data, you want to make it as information. To make the data to information, your real deal first question is how much information is there? If you do something, are you going to lose information, or you're not going to lose information? Okay. For the ordinary attributes, there are information, not just the name. For example, when I do the bond rating, I look at the industry, I say that's a small cap, that's a middle cap, that's a large cap. Those things have meaning, and you cannot swap. Like the student ID, if I assign you different student ID, will not affect your GPA. You know what I mean? Because you are you. But you cannot swap the name of the big cap to small cap. You say we are going to do the same because we just changed the name. That's not. That's ordinary. So you realize if you do a change, you lose the information, you better not to do it. Or you mix some information. Okay. Even to the numerical data, we also have a little bit of different data. Some data is called interval attributes. Interval attributes. Those data allow you to do a linear transformation, like the temperature. It doesn't matter, you use Fahrenheit or Celsius. They have a relationship, one-to-one relationship, and just you use different units. It doesn't matter, you do a shift, use another kind of units. Well, but there are some attributes, the ratio is important. Like the weight in kilogram, in pound, and then allow you do a scale. The unit you can allow to scale, but however, does not allow you to add another constant. That little thing, these little things you need to be careful. Because some data, the ratio, the relative ratio between the two mean a lot, but some does not. For example, when we talk about the capital, they're not only small, big, medium, sometimes the ratio, how much bigger, it's important. You can neutral scale them up and down, but then you're not allowed to make a translation. For example, if I have three companies, one is a billion, one is a million, one is $1 trillion capital, it's okay. You make all those zero gone. You get so one is 1,000, one is 0.001 because their ratio is 1,000. But it's not okay. You mutually add again all $1 trillion. If you add $1 trillion, you know what? You lost the information. This $1 million company will no longer be small, right? So that's the little sensitive thing. That's what I needed to focus. I said, hey, you need to understand what you can do, what you cannot do.